Hey, welcome back to Gaming for Tokens. I'm Marshall, and in this video, I'll be walking you guys through an example that I made, picking up from the last video talking about arrays. This one uses arrays in a major fashion. It's keeping with that same carnival theme we had, a visitor log effectively. It's people entering and leaving the park. It keeps track of the chance of people leaving instead of entering, and it also keeps track of the time in between, and is kind of a neat little runtime script. So I have already written the script, it's right here, and you guys in the comments below should see a link, a Dropbox link to this script. So if you want to go ahead and download that and follow along with me, fantastic. Otherwise, if you just want to keep it for reference, it's pretty well commented, as you can see in here. It looks kind of confusing, but most of it is comments, like all of this and all of that and all of this. So hopefully you can follow along pretty well with this as we go. I already have an object with the script on it, so if you want to do that, go right ahead. Not necessarily a requirement, but I'm going to jump right in. So just like in our last video, this is a public string array with no default value set. So in other words, it looks like that on our object, which is good. That's what we want, because at the moment we don't have any visitors in our park and we don't want to put people. We could theoretically put somebody in the park, but I don't want to for the purposes of this, I guess. I don't know. You'll see why in a minute. So the maximum and minimum interval is the maximum and minimum time between figuring out if we want to add somebody or remove somebody. So it will be coupled with that random.range thing that we covered in the last video. That will determine, this is our max and our minimum range value in that. So we can figure out a time to wait in between removing or adding somebody. The chance of removal is a percentage chance, so in this instance it defaults to 25. So we have a default 25% chance that we will remove somebody instead of add someone from the list. This being the list of visitors, the visitor list up here. Down here, just like in the last video, we have a string array, a private string array, of all the different names that we will be pulling from. So exactly like the last video, we want this not to be public because this is going to stay this way forever, and we can change it if we want. We can add names later via code in this object, but for the purposes of, again, for the purposes of your this tutorial and a couple tutorials from now, public means that we want to edit it in editor. Private means that we don't want to edit it in editor, or rather see it in editor. So we don't want to change this in editor. We want to change this via code, so it's private. The current interval is the current amount of time we're waiting before adding or removing someone. We'll get there. And the timer is the current amount of time in the current interval that we're using. Effectively, it's a stopwatch, if as an easy way to think about it, I guess. So getting into the start function, the first function here is all we're doing is calling a function called setNewInterval. And what that does down here is it says we want current interval, the current amount of time we're waiting, to be a random range between our minimum and maximum variable. Just like I was saying earlier, this is setting how long we're waiting. We want to zero out our timer just in case, because the whole point of this being a separate function, harkening back to the first C# video, is we're going to be doing this a lot. This is a machine that will, as you can kind of see here, a little foreshadowing there, we're going to be calling this function a lot, and in the future we won't know for sure if timer already is 0 or not. Right now it defaults to 0, as we can see up here, but later on when we call this a second time, who knows what timer is going to be, being we are going to be adding things to that. So we want to make sure that we reset our timer so we don't automatically trip it again on the next frame, which is important. So that's what we do on start. So then we jump right into update. That I'm taking you through the steps that the script, well, on the first frame, what would happen on the first frame. So we have all of our variables. We hit start new interval, set new interval happens, and then we go into update. So this line right here is, well, maybe confusing to you guys if your experience with scripting is limited to my tutorials. Time.deltatime is it's really, really important. Time is a a public class in Unity, so you can do a lot with time. You can say time.timescale, which is literally the scale of time. So if you set that to 0.5, everything will move at half speed, unless you're telling it to not be based off of the time. And time since level load is the amount of time in seconds since the level was initially loaded. That's useful for some stuff, like say you were doing a lot of like RPGs and things like that have a current time played counter on them, and this would help that be a thing that you could do. Time.time, I'm not exactly sure what that is. I've never actually used it, and fixed time either. Typically speaking, what you'll be doing is you'll be using Deltatime. That's what I use for everything. That's what I'm doing down here. What Deltatime is the time in between this frame and the last. So timer starts off at 0, and then the first frame, time.deltatime, is probably going to be 0 because we haven't actually... There isn't a frame to compare it against, so that's going to be 0. But the second frame might be like 0.001 or something like that. That is the amount of time in seconds between the last frame. So effectively what we're doing is we're keeping track of the time between each frame iteratively. So we're saying that on the third frame, so much time has passed. On the fourth so much time has passed. And we're doing that every frame, because again, update is called at the beginning of each frame, as it says up here. So this is acting as a timer, hence the name. It's acting as a stopwatch. We're adding time to it, and like a clock, and eventually it will be a certain value or higher. So when it is higher than our current interval, which we set during start, then we want to do some stuff. And this is all stuff that I believe I covered in the first video. So just to take a step back, if this is all really, really confusing to you, I would watch the first video on C# again, or for the first time if you skipped ahead, just so you have some clarification of what some of this stuff is. Like, this is greater than or equals to, so if timer is greater than or equal to current interval, which is what we want, because we want timer to do that. Anyway, if some of this is confusing, go back to the first video on C#, the intro to C# video. Anyway, continuing on. So if our timer is greater than our current interval or equal to it, then we know that we've hit the time that we wanted to wait. So if that's the case, we should, as this comment says, we should see if we will be adding or removing a guest. So what we want to do is we want to say, create a random range between 0 and 1. What this is going to do is it's going if you remember correctly, in the second video, I guess, the intro to C# video, I talked about how floats are often used as percentages, 0 being 0% and 1 being 100%. So 0.5 being 50 and 0.25 being 225%. So what this is saying is generate me a random percentage between 0% and 100%. And again, from the last video, remember that generating floats, which is what the F means, is inclusive. So it will generate 100%. It will not stop at like 99% or 99.999999. It will include the 100%. So just so you know. But it doesn't do that if it's ints. It's really confusing, and I don't know why that is the case, but it is the case. I have theories, as I talked about in the last video, but so anyway, this is saying generate a random percentage, and is that percentage greater than our chance of removal? So again, our chance of removal is defaulted to 25%. So if we're greater than that, then go ahead. The reason why I said greater than and not equal to is because if the removal is 100%, then we actually do want this to be greater than or equal, don't we? Because if the chance of removal is 100%, then we want it to always pass. And if this is 100%, which is the most it can generate, 1, then we want this to, then this is going to be equal to that, and then we definitely want it to happen. Otherwise, our chance of removal for it to always succeed would have to be greater than 100, which would be bad. So that was actually a mistake on my part. But this is accurate. The reason why it's greater than is if it was less than, then technically there would be a 75% chance of it happening if it's defaulted to 25, because there's a higher chance of the number being generated being greater than 25, because 25 is a small number, right? Or 0.25, than it being greater than. So this is correct. Greater than or equal to chance of removal is correct. If we meet that chance, then what we're going to do is we're going to call the add visitor function, which I'll get to in a minute. Just know that add visitor takes in a string, and what we're doing in here is we're saying add a random string from that possible names function, which I did in the last video, but it's basically random.range, and then we're choosing a random integer between 0 and the possible length of the array, which again is exclusive because it's an int. So if that is confusing, head back to the last video, or, well, I hope it's not confusing, but yeah. So that's there, and that's if we do meet the chance for it. Wait, if we're greater than the chance of removal. Okay, so I remember what I was doing here now. Sorry. So greater than is exactly what we want for this, because we're adding a visitor, we're not removing a visitor. Otherwise, we want to remove a visitor. So sorry. The greater than thing is correct. So if we don't meet this chance, if we're less than the chance of the removal, which is 25%, so there's a 25% chance of that happening, go down here, and we only want to do that if the length is greater than 0. So, for example, if there's nobody in the park, we don't want to remove somebody from the park. And actually what we could do instead is say that or if the visitor length equals 0, visitor dot length equals 0. So we can say that if there's nobody in the park, we need to add someone to the park. That way the chance thing doesn't really matter so much. Anyway, so what we're saying here is that if we don't meet the chance and there are people in the park, then we want to... Oh, I see what I did there. It wasn't auto-completing and I was confused as to why. So what I've done is I've accidentally misspelled visitors at the start here. So what I'm going to do is, and this is a good tip for anybody that's having an issue with this, is under search and monodevelop, you can find the replace object, and what you can say is I want to replace visitors with visitors, and you can say all. So what that's going to do is it's going to replace every instance of visitors in the park with the correct spelling. Typos and autocomplete will be the death of programming, I swear. Because if you typo it the first time, then it's going to keep going through the rest of the thing through autocomplete. Anyway, so what I was talking about down here was if the visitor's length is 0, then we want to add somebody. Or if the chance to remove somebody fails, then we want to add somebody. Otherwise, we want to, for sure, and we can change this to an else because this is redundant otherwise, right? Visitors.length greater than 0. But we're only doing the top part up here if it is 0, so we don't need to know this. So we can just get rid of that. Now we have an else. So we can say, if there's nobody in the park or the chances are good, then we can add somebody. Otherwise, we want to remove somebody. And we'll get to these functions in a second. But after that is done, because we're doing something, we're guaranteed to do something. We're either going to add somebody or we're going to remove somebody. We want to set a new interval. So the setting new interval is this function down here that we called on start. It just it resets our timer and it sets a new time that we want to wait for. So there's that. So going on to the add visitor and remove visitor functions, they look really, really intimidating. They're really not that bad. So add visitor takes a name and remove visitor takes an integer, as we can see up here. So this takes, we get a random name from our random length, just like we did in the last video, or our random array, like we did in our last video. We're pulling a random slot of the array based off of the length and 0. And then the other one, we are getting a random range 0 and the length minus 1. The reason why is because that's going to directly correlate with the slots in the array. And I forgot that was inclusive, so we can do that. The inclusive thing throws me off too sometimes. It's like ints are inclusive and floats are ints are exclusive, floats are inclusive. So it's really weird. But yeah, this is the way you want to do it. So if we want to, so we're going to add a visitor. Hypothetically, I'm just going to cover adding visitors for the first part of it, and then go to remove visitors. So adding visitors, we feed it a string, so that's the name of the visitor that we're adding to the list. And to do this is kind of strange. Because of the way programming works and because of the way different objects work, we can't just say, hey, visitor list, add this. I mean, sometimes you can, in certain languages you can. I know in ActionScript you can, but visitors dot, see, there's no like, in ActionScript you can just do this and you can add something to it, but that doesn't happen in here. I'm pretty sure there isn't a way to do that. So what we have to do instead is we have to create another string list that is the same length as our visitor list, but +1. So because we're adding somebody to the list, we have to essentially create a new list that is one bigger. Then we're going to go, we're going to loop through that list just like we did in the last video, if you remember correctly. And we're going to set the new list slot to the mirrored old list slot. So the new list that we made here and the visitors list, we're going to essentially make these two the exact same thing, but temp names is going to have an additional slot at the end of it that's going to be empty. And that's why on the for list here, I'm using the visitors length instead of the temp names length, because I don't want to hit that last slot. I just want to go for the entire length of visitors. I don't want to go for the length of temp names. Really hope that makes sense. But basically just think about it this way. If you have, again, a dresser and you need to add a new shelf to that dresser, you can't just put a new shelf in the dresser. You have to go get a new dresser that is one size bigger, and that's what we're doing here. And then we're going to go through that new dresser and we're going to take everything out of the first dresser and put it into the new one, and then we have an empty shelf at the end because there's one shelf more. I hope that kind of sort of makes sense, but that's basically what we're doing here. And then because the last slot we know is going to be empty, we can set that to whatever we passed into the add visitor function, which is the new visitor name. So we can set that to this. And we know that visitors.length normally would be bad if we're using that on the visitors function. Because we're not, it's fine, because this is going to be one slot bigger than that. We know that through math. So the last slot in temp names is going to be the new visitor name that we have. And then the last thing that we're going to do, which is kind of weird, is we're going to make our old visitors list it's going to be equal to the temp names list, which is the new one that's one bigger. So I'm trying to think of a good analogy for that, and I can't. But basically, this is we've created this new dresser, and then we're gonna say, "Hey, old dresser, be that dresser," and then this one's gonna go away. The temp names one is just gonna disappear because it only exists within this function. I hope that makes some sort of sense. I don't know, but basically the whole dresser thing works up until that last part. So we need to add a new shelf or a new drawer to visitors, but in order to do that, we need to create a new dresser that has an additional shelf. Take everything out of the old dresser, put it in the new one, and then we just have the new one, and we use that one as visitors instead. Does that make sense? I hope it makes sense. I don't know why I'm asking. It's not like there's anyone listening to me right now. Maybe in the future, but not right now. So anyway, that's what add visitors does. It adds someone to the list. And this is that someone. And this is that list. And then this becomes that list, if that makes sense. So removing a visitor is basically the same thing, but reversed. So we create a new list, again called temp names, and it is, but we also feed an integer into this, and that's important because that's going to be the slot in the visitors the visitors list that we're going to take out. So that's that part's going to be kind of confusing, but think about it like we have this dresser again, and we want to get rid of one of the shelves. We could just pull the shelf out, but then we have this like hole that nothing is there in the dresser. So instead, what we do is we go out and get a new dresser that is one drawer shorter than the other one was, and then we move everything into that new one. And then the stuff that doesn't fit, we just throw away. So that's basically what we're going to do. Here's our new list, temp names. And for this particular instance, I need a new integer. I need something to keep track because I need to go through two different lists at the same time. So this is where it gets kind of convoluted. So we have our old list just like we did before, except instead of adding one, we are subtracting one here. And we're creating a new integer, just like we have done in the past. And just like we did up here, we're going to create a for loop. This one's a little bigger, that goes through visitor's length. And for this particular one, I'm using j because I already used I, but it doesn't matter what this is called. It's just an integer, just like that's an integer. So we're going to go through visitor's length, and we're going to check to see if j equals the visitor to remove, which is the variable that we passed in. If it doesn't equal that, then we want to do this. If we want to mirror it over just like we did before, we want to then take the stuff. So like if we're removing the third drawer in the dresser, we want to first move over the first drawer, then the second drawer, and then we want to skip the third drawer, and then we want to put the fourth drawer in, and then the fifth drawer. But we don't want to put the third drawer in. That's basically what I'm saying here is if what we're looking at currently is the one we want to take out, then we just don't want to add it. And then I'm actually doing a debug log here for we'll see what this does in a second. But basically this is telling me that, hey, look, a new guy entered, and this is saying, hey, look, a guy left, and this is who. And then again, what we want to do is we want to tell our old list to become our new list. So we want to mirror that over for consistency's sake. And that's all this does. So kind of a refresher. We start by setting our interval. So we start by saying, here's how much time we want to wait for the first person to appear. And then here's our timer. So here's how long we have waited. If we've waited long enough, then we want to see if we want to see if we want to remove somebody, and if we do, we want to go here. But if we don't want to add somebody, or there's nobody in the park, then we want to add somebody. Either way, though, we're going to want to go set a new interval, so we want to do that again at the end of whenever we've decided that we want to do stuff. And when we add a visitor, what we want to do is we want to create a new list of people, put the guy on that list, and then make our old list that new list. And if we want to remove somebody, what we want to do is create a new list that doesn't contain the guy we want to remove, and then make that new list our current list. So I hope that makes some sort of sense. And again, all of this is pretty well commented, I think. I'm usually pretty bad about commenting my code, I admit, but I think I did a pretty good job on this. And if you guys want to see it in action, I have it attached, and I will hit play and head to the console, and we will see people being added to this visitors list. So Jeffrey has entered the park. There's now one person in the park. Jeffrey has left the park. Now there's 0 visitors in the park. So Jeremy has entered the park, and now there's 1 person in the park. Josh has entered. Now there's 2. And now Jonathan has. Now there's 3. So you can just sit here and watch this for hours, and maybe the park will get a ridiculous amount of people in it. Maybe everybody will just constantly leave. And you can edit these values as things go. So you can say that this is 3. So now people will start to join and leave faster. If we change these to 3 and 1, you'll start to see it becoming more frequent. If we change the chance of removal to 0.5, people will start to leave more frequently instead of being added more frequently. So see how that was... Yep. And there we go. So people are adding and removing at 50-50 chance, and people are coming and going really, really quickly. So again, if we change this max interval to like 0.5, oops. max interval 2.5. I'm going to pause it really quick and change this to someone, and change this to 0.5 and change this to 0.125. You'll see it's going to start going really, really, really fast as soon as I unpause this. So see how people are coming and going really, really quickly? And right now we have like 29 people, 30 people, somewhere around in there in our park. Anyway, and it's not just the people at the end that are coming and going. Sometimes it's people like in the middle sometimes that leave. And we can see that here. Well, we can't really see which one's who because I don't have enough names, but you get the idea. And that's what this does. So that's kind of an example of a runtime script is what it would be called, because it happens during runtime. It's not like normally code. The difference between code and scripting is that scripting happens during runtime, and code can happen during runtime, but most of the time is like stuff that does stuff in the background, whereas scripting is stuff in the foreground, I guess is an easy way to think about it. So yeah, this is a runtime script, and it's on an object, and it does stuff. So I hope this was kind of helpful, and again, if it wasn't, or if you have any questions, or you think this video was horrible, let me know why and like what you want me to do to improve, either on Twitter. And I did enable the comments in the videos, so hopefully, I don't know, something good will come out of that. The reason why I didn't in the past have the comments enabled was because a couple of my favorite YouTubers don't have comments enabled, and they have very good reasons for why, but we'll see what happens. If there's an absurd amount of abuse going on in the comments, or, you know, typical YouTube comment crap, then I'll disable them again. But for the time being, they are enabled, and feel free to use them to tell me what I should do better or what you want to know how to do. In the next video, I am thinking about covering, I don't really know, probably some collision detection stuff, and dealing with the first-person controller I think would be a good place to go from here, but don't necessarily believe that 100%. Take that with a grain of salt. It might be something different. I don't know what's going to be next, but whatever it is, it will hopefully be helpful to some. Anyway, I'm going to attach this script now that I've edited it especially, and make sure you download it and check it out and dissect it, and keep making games. Yeah. So anyway, thanks for watching, and bye-bye.